Hello, and welcome to All Together Now, Key Concepts about Climate Change. Episode 1, Is it real? The first thing people want to know is whether climate change is real. This episode will address how the information is collected, which answers that question. The average global temperature of planet Earth has increased over its pre-industrial level. 2/3 of the warming has occurred within the last 50 years, so during most of our lifetimes. A degree Celsius or 2 degrees Fahrenheit doesn't seem like much, but it's like you having a fever. Every 1/10 of a degree counts. It sets conditions in place which never existed before during the entire time humans have been on Earth. We know this through multiple lines of observed evidence. How do we know? By aggregating vast amounts of data from sources below, on, and above the surface of our planet. Ocean temperature data comes to us from buoys deployed around the world. Scientists of many countries participate in the hard work of deploying these, maintaining, collecting, and analyzing the data. Buoys collect data from all of Earth's oceans. The different science organizations work together and share their data, and this helps them to check the accuracy of their findings. This monitoring does show and verify that ocean acidity has increased and ocean temperatures have risen. This map is from the National Oceanic and Atmospheric Administration, Science on a Sphere. You'll see that some of these are United States organizations, some are international collaborations, some of the buoys are set on the coastline or on offshore platforms near the coastline and the beaches, or put in lighthouses. Others are moored to the floor of the ocean, collecting deep water information, and others float with and follow the current, are carried by the current. And the kinds of information that's gathered, including temperature, also salinity, and information about the currents and how they're changing. There are other land-based methods. Historical data gathered from tree rings and ice core samples verify that the average global temperature of our planet has risen. Land-based data collection includes monitoring changes in our air. This is Mauna Loa Observatory. What you see behind it are clouds. It's above the cloud level. One marker of how the chemical composition of our atmosphere has changed is ppm, parts per million. Parts per million of carbon dioxide in Earth's atmosphere have increased over the last 120 years from 300 parts per million to 420. This changes the way our planet's atmosphere handles light and heat. To put that into perspective, the entire time humans have been on planet Earth, parts per million was always under 300. This monitoring does show and verify that new conditions are in place which warm the Earth. Satellites provide observations of change in loss of forests, expansion of deserts, disappearance of glaciers, eroding of coastlines, and changes in our polar ice caps. A time lapse from NASA shows the North Pole from the satellite data. It compares the amount of sea ice at its smallest amount every summer to the next year's smallest amount. Changes in the amount of sea ice can disrupt normal ocean circulation, thereby leading to changes in global climate. Even a small increase in temperature can lead to greater warming over time, making the polar regions the most sensitive areas to climate change on Earth. So we're going to pull up this video now. I'll show you. So this comes from, this is a visualization from NASA. So the Scientific Visualization Studio. And we'll make it large. Now, as you're watching this, it's going to put the dates. I want you to pay attention to the dates and think where you were at that time. And when people you know and love were born, when you were born. Let's take a look. So this is comparing, again, this is comparing the lowest, smallest amount of sea ice each summer, which is at the end of summer. So I'm going to pause it right here. And we'll take a look. And we'll go over again what this means. So in 1979, there was about 7 square kilometers, 7 million square kilometers. At the point when the sea ice was smallest. Now, sea ice is the ice that floats on the ocean. And when it melts, it exposes more of this deep blue color of the ocean. Now, as you know, deeper colors absorb more heat. So the actual ocean surface absorbs more heat when the ice retreats. So for instance, at this point and at this point, so at this point in 1992, looks like, about 92 or 93, at this point in the summer, the ocean was absorbing a lot of heat because its white reflective cover had been taken away. That's called albedo, which is the measure of reflectivity of surfaces on our planet. So let's continue. So that's called a positive feedback loop, meaning that as more ice melts and as more blue ocean is exposed, the ocean warms up, which in turn melts more ice, creating a positive feedback loop. Very difficult to get out of that once it's started. So here we go. We're at 2005. So you can look on here if you were if you're in your 30s or your 20s, or maybe you're a teenager. Here you go. Look at where you were born, and you can see what was the Arctic doing in my lifetime. Here you go. 2007, a big dip, and which, it regained some of the ice, but then it tended to lose even more because there was more ocean that was warmer. Let's keep going. So I'd like you to think about where you were at the time, and also where your loved ones were at the time. And notice that although it does go up and down, the overall trend is down. That's some of the kind of vital information that we can get from satellites. So as you can see, it is not just one indicator, not just one source of information, which leads scientists all over the world to conclude that the temperature of our planet has risen. It's the hard work of consistently and painstakingly collecting data over many years from many sources, confirmed by the scientists of many countries from many different disciplines. I hope you'll join me in the next installment of this, where we can go deeper into this very important subject. To conclude, is it real? Multiple lines of evidence verify that it is.